So let's start our today's class. So hello everyone, this is lecture 6 on discrete mathematics, and in this lecture we will resume our previous lecture only. In the previous lecture I have just leave this as homework for everybody. So I hope you have solved it, and let me show you. Okay, so Px is a proposition. It is given as x is not equal to 1. Domain is what? It is positive integer. So x is not equal to 1, and for every y, for all y, that means for every integer you are checking, there exists z, x is equal to yz. Okay, so directly and directly you want to say if x is equal to yz, then y is equal to x or y is equal to 1. See, what do you mean by x is equal to yz? X is equal to yz means z is equal to x by y. Now since z is an integer quantity, so x divided by y should be integer. Now x divided by y integer means what? Y is factor of x. Y is factor of x. So directly and indirectly they just want to say that y is factor of x. Okay, so now read it. X is not equal to 1, and for every factor of x, either y should be equal to x or y should be equal to 1. That means every factor, so whatever factor you think, it should be either x or 1. So only two factors, that is what? Prime number. So this proposition represent prime numbers. Okay, yes, you can take snapshot. I will jump to the next slide. Yes,
Done,
I'm jump.
sir.
Okay. Next is Px is x is prime number, Gyx is y is greater than x, and they want to say for all x, Px implies there exists y, Gyx and Py. So Px means x is prime. So if x is prime, for every x, if x is prime, then there exists y such that g of yx and Py. That means what? Y is greater than x. This means what? Y is greater than x. Y is greater than x, and this means what? Py means and y is prime, and y is prime. So what they want to say, for every x, okay, for every x, if x is prime, then there exists y which is also prime number and it is greater than x. So there exists prime number greater than the given prime number. Okay, so directly and directly they want to say for all x na. So for see, you just give me any prime number, I will say I will be able to find a prime number greater than the given prime number. Okay, so given any prime number, they want to say given any prime number, we can have a prime number greater than the given number, greater than given prime number. Okay, so you just give me any big prime number, say like I am assuming that this is a prime number. Okay, I'm assuming this is a prime number. Now I will say that I will definitely find a prime number greater than this. This is a very beautiful theorem in mathematics, and I am not going into detail of that. This theorem is saying that if you find any prime number, I will say that I will definitely find a prime number greater than the given prime number. Okay, so you can apply this theorem on natural number also. Like you write any number, any natural number. Okay, so let me write a natural number, and I will definitely say I will find a natural number greater than the given number. Obviously, you just replace 2 by 3 and so on. So from the morning you write number. Okay, from morning you start writing a number 1, 2, 3, 6, 4, and so on. You keep on writing number from morning till evening, and when in the evening you stop, I will say I will find a greater number which you have written. I will find a greater number than the number which you have written. That is for natural numbers, and by intuition you can easily say that. Okay, but the same thing apply for prime numbers also. So we can find a prime number which is greater than your given prime number, and it has been proven statement. Okay, yes, so that theorem is written logically like this. So now again you can read it. For every prime number, for all x, okay, sorry, x domain is not given now. So for all x, that means for every number, if x is prime, then we can definitely find a prime number greater than the given prime number. That is the basic thing. Okay. So now this statement is true for what? Domain is real number, domain is integer, domain is positive integer, and this. So if domain is real number, now you may argue, sir, for prime number logic is applicable only for positive integers. Nah? Prime number definition is for positive integers only, like negative 30. Okay, this is meaningless. Negative 3 is not a prime number because prime number is always positive integers. Okay, yes, and say if I write 3.2 or 1.2 and so on, these real numbers are also never prime numbers. Okay, so prime number is restricted to positive integers only. Okay, prime numbers is restricted to positive integers only. Prime numbers positive integers only. So now what is the domain they want to say? Domain is positive integers. C option is 100% correct. But see, this is an MSQ, that means multi-select question. More than one answer can be correct. If they want to say domain is real number, then also not a problem. Why? Because first I am checking that is it prime number or not. If it is prime number, then I am saying I will be able to find a prime number greater than the given prime number. Are you getting it? So if we have a domain of real number also, no need to worry at all. These are the real numbers. So now you will keep you will take this real number and you will say, is it a prime number? If you think that it is a prime number, then we will apply the definition like this. Then we will go for further. If this is not a prime number, then we will not go further, because P implies Q. In P implies Q. If P is false, then it hardly matters. Q can be either true or false. This P implication to Q will be always true. Okay, so that's why if the domain is real number also, no problem at all, this definition will work for real numbers also. So you okay, and I think you already know na, positive integers are subset of real numbers. Okay, so no problem. Similarly, if I say domain is integers, no problem, negative integers are also coming into the picture. And if by chance you pick a negative integer, you will immediately say it is not a prime number, you just leave it. Okay, so because I am checking here now, if P is prime, then I have to check. If P is not prime, it hardly matters to me. So this is also correct. Okay, A, B, C option are correct. Now let me see the D option. What D option is saying? 1, 2, 3 up to 100. So this is a finite set is given to you. Finite set is given to you. So what will be the last prime number? If we see, last prime number will be, I think, 97. Okay, 97 is the last prime number from 1 to 100. You can check it out. Now after 97 there is another prime number, say 101. So what I am saying from this definition, if x is prime, then there exists y, okay, such that y is greater than x and y is prime. So now in this set I am not able to find a y. So obviously D option is wrong. Okay, D option is wrong. And by the way, you can check it out yourself, na. So you are getting intuition of infinite sets only, but here finite set is given, so it can never be true for this finite set. You can check it out like this also. Okay, now please take snapshot. I will jump to the next slide. I'm jumping now. Okay, so now our logic is completed. Now we are going to start combinatorics. So in combinatorics, we will study three parts: PNC, that is permutation combination. Second is summation, and third is recurrence relation. Recurrence relation we will not study because you will study that in your algorithm subject. So we will leave it. Permutation combination we will study. Binomial summation, if I will get time, I will definitely explain it. Otherwise, I will leave it because it is not so important. But generating function is very, very important. Almost every year, one question is coming from the generating function. So I will explain you that also. Okay. So in combinatorics, we will concentrate on your PNC, permutation combination, and generating functions. Okay. These are the two main topics in combinatorics. Okay. So you can take snapshot. I will jump to the next slide. Okay, I'm jumping
Done,
now.
sir.
Okay. Next is so P and C. So many of you will get confused that sir where to apply permutation, where to apply combination, and so on. Okay, so there are many difficulties in this topic. This is very confusing also, but we will study it very meaningfully. Okay, so I will tell you 9 categories of problems. 9 categories of problems, and we will study all these categories. And once we will study all these categories, so after that if any question comes, then you will simply find whether this is category 1, category 2, category 3, or category 9 question. Now accordingly you will apply the formula and get the answer, so no need to worry at all. So permutation and combination is not a random thing. Many teachers and many students also learn it randomly. Okay, like some question will come and you will say okay apply this formula, some question will come, okay apply this, and so on randomly. You should not study it randomly. Rather permutation and combination is a proper system. Okay, it is a proper system. And here you just have to identify the category, which category question is there, simply apply the formula and get the answer. Okay, so how you will identify the category, don't worry, we will solve lots and lots of questions. By experience you will get more clarity. Okay, we will study lots of questions. Okay, that is the basic approach which I will follow to teach permutation and combination. We will not study randomly like I keep on solving questions and questions, you keep on answering them and so on. No, it will never help you in PNC, because sometimes question will be asked out of the box and you may not be answered that. And GATE is famous for asking out of the box questions. Yes. So if you want to take any snapshot you can take, and I will tell you now all the 9 categories, what are these 9 categories and so on. Okay. Yes. So these are the 9 categories. So see, this is a table. Okay. This is permutation. This is permutation. This is combination. So permutation without repetition, permutation with limited repetition, permutation with unlimited repetition. Similarly, combination without repetition, combination with limited repetition, combination with unlimited repetition. And these are the formulas. So total 6 categories we have done. 1, 2, 3, 4, 5, 6. These are the 6 categories. And then 7th is distribution, 8th is inclusion exclusion principle, and 9th is pigeonhole principle. So total 9 categories we have to study. So the only thing is you have to first, whenever question comes to you, you have to first check which category is this question, and accordingly you will apply formula. Okay, like you identify that it is permutation without repetition, immediately you will apply the formula NPR and get the answer, and so on. Okay, yes. Please take snapshot. I will jump to the next slide. So now we will study category by category. So first category is permutation without repetition. So let me show you that category. Okay, I'm jumping to the next slide now. Okay, so before that, let me cover a small difference between permutation and combination. Okay, so permutation means, this is very important point. Whenever order matters, then you will apply permutation, and whenever order does not matter, then you will apply combination. Okay, that is the first important point which you should remember. Okay, whenever you are getting a sense that order does not matter, you will apply combination, and whenever you get a sense that order matters, then you will apply permutation. Like I say arrangement. Okay, arrange students in a row, or you can say arrange letters, arrange words, arrange numbers, and so on. Arrangement, whenever you see arrangement kind of thing, you will say okay, it is permutation. And whenever you say select or collect, you will say combination question. Like I will say select 2 students from a group of 10 students, so you can select any 2 students, and order does not matter, you pick first boy or first girl, and so on. And definitely it depends on question to question, but generally order does not matter. Now you, who you pick first, who you pick second, and so on, you are just picking 2 students, that's it. Okay, so select, collect. Okay, that is combination point of thing. Then sequence means permutation, set means combination. Okay, sequence means order matter, and in a set I think you already know order does not matter. Okay, A and B, this set is same as saying as B A. So whenever we have a set kind of thing, then combination, sequence kind of thing, then permutation, number, words. Whenever you are talking about numbers and words, that is permutation only. Okay. For example, 1, 2, 3 is not same as 3 to 1. These two numbers are different. Okay. So clearly here order matters, na? So number, words, permutation. Set, subsets. I think I have told you this is combination. Boxes kind of thing, when boxes kind of things come, permutation. When committee, team, interview, for interview you want to select 3 persons, so you can select any three. For making team you can select 3 persons, you can select anybody. Okay, any 3 persons. Or committee, we want to make a committee of 10 persons, so you can pick any 10. Order does not matter, na, which you pick first, which you pick second, and so on. Okay, so here we will use combination. So don't worry, I have just given you a very small introduction that where we should apply which keyword is applied on which thing, and so on. Okay, so slowly we will dig deep into the topics, we will get more clarity, but generalized thing is this. Okay, and of course there are many exceptions also, so I will tell you all these exceptions one by one. Okay, please take snapshot.
Done, sir.
Okay, so now we will start the first category. What is the first category? Permutation without repetition. Formula is NPR. See this. So how many 5 letter words with distinct letters from English alphabet? So English alphabet is from A to Z. How many are these? 26. So what they are saying, how many 5 letter words with distinct letters from English alphabet? So how many 5 letter words? Okay, 1, 2, 3, 4, 5, 5 letter words. So the answer to this question will be 26P5. Okay, and my suggestion is do not go by formula. Of course I have written the formula NPR and all, so you will get confused what is N, what is P, and so on. So better is do not go by formula. Okay, simply apply box method. Let me tell you what is box method. Box method is very easy, you just make box. Okay, so how many what is the length? 5 letters, so you will make 5 boxes, 1, 2, 3, 4, 5. Okay, so now distinct, since I have used the word distinct, so that means what? Without repetition. Without repetition. No doubt I have applied the formula and solved it, but my kind suggestion is do not apply this formula in gate exam. Why? Because obviously gate exam will not ask these kind of very simple questions. Okay, they will apply lots and lots of constraints and they will make a fancy question. To answer such fancy or difficult questions, you should know this box method. So directly and indirectly I want to say, do not remember any formula, you should know proof of everything. Yes, yeah, so let me tell you. So at the first place, how many choices are there? Since 26 letters are there, so at the first place from 26 you can pick any one. Now after picking one, obviously now you are left with only 25 letters. Now at the second place you can take any one of the 25 letters, then again 24, 23, 22. So what will be our final answer? Our final answer will be 26 into 25 into 24 into 23 into 22. This is my answer. Now some of you will say, sir, why we are doing multiplication, why we are not doing addition and all. So many of you will get confused about when to apply addition, when to apply multiplication, and so on. So for that we should know fundamental principle of counting. Let me show you that in the next slide. So please take snapshot of this, then I will jump to the next slide. I'm jumping now. So next is fundamental principle of counting. What it is saying, so the basic confusion in everybody minds is when to apply multiplication, when to apply addition. So let me show you. See this. For example, we have a city A, this is city B, this is city C, and this is city D. From A to B, there are 3 highways, or there are 3 ways to reach from A to B. From B to C, there are only 2 ways to reach. Okay? And then from A to D, we have say 3 ways. Or let me write 4 ways. Okay? From A to D, we have 4 ways. And from D to C, we have say 3 ways like this. So now I want to ask a question. How many ways to reach from A to C? A to C, how many ways? So what is the answer? I will say you pick one highway from A to B like this. You pick this highway. Now there are 2 ways to reach from B to C. Similarly, when you pick the second highway, again there are 2 ways to reach from B to C. When you pick the third highway, again there are 2 ways to reach from B to C. So what kind of sense we are getting? So from one highway, when I pick one highway, I am getting 2 ways. Then when I'm picking the second highway, I'm getting 2 ways. When I'm getting the third highway, I'm getting 2 ways. So 2 plus 2 plus 2 total. How many ways are there? 6 ways. I think it's really very simple. Na? 1, then 2 ways, then 2 ways, then 2 ways. So total 6 ways. So how can I write 6 directly? I will write it like this. So there are 3 ways. There are 2 ways. So 3 multiplied by 2, that is 6. Okay, that's why I have done here multiplication. Now let me show you here. So from A to D, how many ways are there? 4 ways. From D to C, there are 3 ways. Now I think you have got it. I will pick one of the highway from A to D, and there are 3 ways to reach from D to C. Then for the next again 3 ways. For the next again 3 ways. For the next again 3 ways. So 3, 3, 3, 4 times I will add, that is 12. So how I can write 12? So 4 into 3, that is 12. So now can anybody tell me what are the total ways from reaching A to C? Total ways are 6 plus 12, that is 18. Why I have written a plus here? Obviously, na, total ways I have counted. Na? So 6 ways from here, 12 ways from here. So how many ways are there? Obviously 6 plus 12, that is 18. Okay, so this is the basic fundamental principle of counting. Okay, so multiplication means whenever, see, when we will apply multiplication, when task is not yet over. For example, I want to reach from A to C. Task is not over when I reach from A to B. Task will be over when I reach from B to C also. So whenever I am in between or task is not over, then I have to do multiplication. So what fundamental principle of counting is saying? I am having a big task and I have divided it into say 2 tasks. Then to complete this task, I have to multiply the number of ways of doing T1 and T2. Okay, that is multiplication. So big task is divided into small tasks. So number of ways to do small tasks, all of them will be multiplied. Like you want to reach from A to C, but you have divided it into 2 tasks, A to B and B to C. So first you will do A to B and then you will do B to C. So A to B number of ways, B to C number of ways, they will be multiplied. Similarly, from A to C, I can reach from A to D and D to C. Okay, so 4 ways here, 3 ways here. So A to C, I have broken it into 2 tasks, A to D and D to C. Okay, so yes, so obviously since after reaching D, our task is not yet over, I have to reach C also. So obviously I will do multiplication, that is 4 into 3, 12. So now I will say total 6 ways to reach A to C via B and total 12 ways to reach C via D. So I have reached in these 6 ways I have reached the C, and in these 12 ways also I have reached the C. So now I have to do addition. So that's why I have done addition here and I have got 18. So like this. So and there are lots and lots of examples. So I can say I have say 3 shirts and 4 pants. So how many ways I can dress up? Only shirt, I am not dress up. Only pant, I am not dress up. I have to wear both of these. So obviously how many ways? 3 into 4, that is 12. So you can think like this. You just pick one shirt and you can match it with four pants. You pick another shirt, match it with 4 pants. You pick another shirt, match it with 4 pants, and so on. So total 12 ways are there. So that's why multiplication is there. Okay. So whenever big task is divided into small task, multiplication will come into the picture. Okay, so same here. So now see this. So 26 5 letter word I have to make, na. So I have picked one letter from 26. There is for first place there are 26 choices. So I have picked one of the choice. Work is over? No. Now at the second place I have 25 choices. I will pick one of the letter from 25 letters. Work is over? No. I have to pick another, I have to pick another, I have to pick another. So obviously multiplication sense is coming. That's why I have done multiplication. Okay, now so now you can take this snapshot. So I will jump to the next slide. I'm jumping now. Next is how many 5-letter words from English alphabet. So they have just said this. So by default you have to take repetition. If repetition is not there, they will properly mention distinct. See this, what is the difference between this question and our new question? Here we have distinct, but here we do not have distinct. Okay, so the only difference is this. So now what we should do? So this is clearly unlimited repetition kind of thing, because from English alphabet I can repeat the words. Oh, sorry, I can repeat the letters. So 5 letters, no? So 1, 2, 3, 4. Yes. So first place 26 English alphabets are 26 letters. Sorry, 26. 26 letters. So 26 choices at the first place, then 26, then 26, then 26, then 26 because of repetition. So all will be multiplied. So what is the answer? 26 power 5. So if you want me to show you the category, I will say permutation with unlimited repetition is this thing, because unlimited repetition is there. So unlimited number of you can say uh, uh, characters are there with you. Okay, unlimited characters are there, A, B, C, D, and so on up to Z. A to Z, all are there in unlimited occurrences. So it is permutation with unlimited repetition. And see the formula: permutation, unlimited repetition, n power r. So what is n, what is r? I am not going into details and all. It will waste our time. And I have told you many times, you will not apply this formula in GATE exam, because such kind of simple question will never be asked in GATE. How many 5-letter word with English alphabet? This is really very simple question, and they will not ask these questions. I'm just building the background for the GATE questions. Okay. So best method is box method. So box method, I think you have got it. It is applied for permutation with limited repetition, unlimited repetition. Everywhere it can be applied. No problem. Okay. See, first one was no repetition, and next is unlimited repetition. So I should say like this. I should say properly. Okay. Box method can be applied for permutation with unlimited repetition and permutation with no repetition. Permutation, unlimited repetition with no repetition, and they can be applied for with limited repetition also. Okay, I will tell you, don't worry. This is really very beautiful method. Okay, it will solve lots and lots of questions. Okay, yes, please take snapshot. I will jump to the next slide. Okay, I'm jumping now. Next is 5-letter words start with A, end with Z without repetition. So same. So that's why I was saying, constraints will come into the picture. So now I have constraint. I will make the box. So start with A. So yes, end with Z, and I am saying without repetition. Since I am doing without repetition, so I will say 1 and 2. 2, you can say characters are over. Okay. So how many are left? 26 minus 2, that is 24. So here I am having 24 choices, here 23, here 22. I think you have got it. Here 24 choices are there. One I have consumed here. So 1, 2, and 3 are consumed. So 23 are left here. So again 1 is consumed here. So I think you have got it. So now what will be our answer? See this. There is only one choice here, that is A. A should come here. There is only one choice, that is Z should come here. So 1 multiplied by 24 multiplied by 23 multiplied by 22 multiplied by 1. So final answer is 24 into 23 into 22. That's it. This is my answer. Please take snapshot. I will jump to the next slide. These are very simple question. I should not waste time here. Yes, I'm jumping now. Yes, hanged. Yes, now it's okay. 5-letter password start with A and end with Z. Same. See, password means what? By default in password, you repeat the characters or not? Obviously, we repeat the characters. So obviously, by default means unlimited repetitions. Okay. Yes. So it's very simple. Starting with A, ending with Z. 5 letters, na? So here what I will say 26, 26, 26. Why? Because repetition is allowed. That's why. So how many choices are here? Only one. That means A should come. Here also A should come. Here 26, 26, 26. Everything will be multiplied. So final answer is 26 power 3. Okay. Next, start with A or B and end with Z 5-letter password. Start with A or B. So 1, 2, 3, 4. Start with A or B, end with Z, 5-letter password. 5-letter password 26, 26, 26. Password means unlimited repetition. So A or B, how many choices? 2 choices. Z only, 1 choice. So 2 into 26, 26, 26 into 1. So 2 into 26 power 3. Please take snapshot. I will jump to the next slide now. Okay. Next is start with vowel and end with Z, 5-letter password. Okay. Yes, 5-letter password. So what we will do? Password means unlimited repetition. Start with vowel. How many vowels are there? A, E, I, O, U. Five vowels are there. So I'm not writing just to save the time. Five possibility here. All the vowels A, E, I, O, U. You can write it. And end with Z. So only one possibility. Passwords are there, na? So 26, 26, 26. Final answer is 5 into 26 power 3. Next, what if we say no repetition? No repetition is simple. See, what we will do? 1, 2, 3, 4. 1, 2, 3, 4, 5. Yes. So here we have applied Z. Okay. So, and here we can apply 5. From the 5 vowels, I can take any vowel here. So now see this. One character gone here, one character gone here. So how many are left? 24 are left. So 24, then 23, then 22. So what will be our answer? 5 into 24 into 23 into 22 into 1. This is my answer. Okay, yes. So I am writing 1 so that you get more clarity that why this is coming and all. Because multiplying by 1 will not affect our answer. But still I am writing so that we get more proper clarity about why for which box we are doing which thing. That's why. Please take snapshot. I will jump to the next slide. Okay, I'm jumping now. So 10 persons enter in a bus and 4 seats are vacant. How many ways they can sit? This is a very beautiful question. 10 persons enter in a bus and 4 seats are vacant. So how many seats are vacant in the bus? 4 seats are vacant. These are the 4 seats which are vacant. Okay, and obviously it is not the case that they will be side by side. They can be other some other places also, but I have just written our, I have just combined them because I want to find ways. That's it. So 10 persons enter into the bus. So at the first place, how many choices are there? From these 10, anyone can sit. 10 choices. At the next place, 9 choices because one person has already sit. So I think you have got it. What kind of sense it is giving? No repetition kind of sense it is giving. There is no repetition. Na? How one person can sit on the 2 places? Meaningless thing. Then here we have 8 choices and here we have 7 choices. So 10 into 9 into 8 into 7. This is my answer. Okay. Yes, you can take the snapshot. I will jump to the next slide now. Next is, this is very important scenario. Please try to think like this. Try to think everything in terms of combinations. Okay, so by box method I have explained you. But with combination, how we can explain? See, first of all, I should tell you the formula. I have not tell you the formula. I think you already know what is NCR. NCR is n factorial upon r factorial n minus r factorial. What is NPR? NPR is n factorial divided by r factorial. Sorry, divided by n minus r factorial. So from this, mathematically, I can say what is NPR? NPR is NCR multiplied by r factorial. Are you getting it? You take NCR and you multiply it by r factorial. R factorial will be cancelled out. Finally, this will be remaining now, and it is nothing but NPR. So NPR is this. Mathematically, I have told you. So now let me tell you in the intuitive way. So what can I say? What do you mean by NPR? NPR means you from n objects you pick r objects and you arrange them also. So now see this, what we are doing, same thing. NPR means you from n objects you are picking r objects and arranging them. But what this is saying, this is the same thing. NCR means what? You are picking r objects from the n objects. Now after picking them, you will arrange them. It's just like that. Okay, so for example, I am having 3, 4, 5, 6 items I am having, and you just pick 3 items, okay, and arrange them in a row. Arrange them in a row. So after picking 3 items, so how many ways to pick these 3 items? 1, 2, 3, 4, 5, 6. 6 items. From the 6, you pick the 3. 63. Okay. After picking, you arrange them. So how many ways to arrange them? 3 items. 3 factorial ways. So first place 3 choices, then 2 choices, then 1 choice. So 3 into 2 into 1, that is 3 factorial. So it will be multiplied by 3 factorial. And it is nothing but 6p3 only. So I think you have got it. So let me write it, okay, so that you get more clarity. Let me write it. What do you mean by NPR? So pick R or directly see. If I want to write, I will say arrange R objects. Arrange R objects from n objects. So how you can arrange them? First you have to pick them, na? So NCR, what NCR is saying? Pick R objects from n objects. Pick R objects from n objects. And what R factorial is saying? Arrange them. So multiplication means what? Work is not yet over. Now, so you have picked them. Work is not yet over. So I will arrange them also. So same thing I have done in NPR also. So NPR is nothing but NCR into R factorial. So that's why I was saying try to think everything in terms of combination. So now you will not get confused where to apply permutation, where to apply combination, and so on. I will simply say everything you do by combination. Okay, after combination you will try to arrange them. That is the basic way. Okay, so like this. So let me give you small shortcuts also, so that you will be able to solve questions more precisely. So NCR means out of n you are picking R objects. Okay, pick R objects from n object, that is NCR. I have told you, pick R objects from n objects. So formula for NCR is this: n factorial r factorial n minus r factorial. But in the shortcut manner, see this. If I want to expand 6C3, I will simply say like this: you expand, you keep on subtracting 1 from 6 3 terms. You will write 3 terms. So 6 into 5 into 4. Because of this 3, you will divide it by 3 factorial. That is the basic way to expand 6C3. Okay, and multiplied by 3 factorial, obviously. So 3 factorial cancelled. So you will get n 6pr. Sorry, 6p3. So what is 6p3? 6p3 is this only, 6 5 into 4. So now no need to apply formula and all. Simply say like this: 6p3 is 6 into 5 into 4. That's it. No need to apply n factorial upon n minus r factorial and so on. It will waste our time. So 6p3 is 6 into 5 into 4. Okay, I say the same way if I say 7p3. Okay, or say let me say it a big number. Let us take a big number. 12p5. So how you will say 12 into 11 into 10 into 9 into 8. 1, 2, 3, 4, 5. That's it. This is my answer. This is 12p5. Okay, and if I say 12c5, then what I will do, I will say 12 into 11 into 10 into 9 into 8 divided by 5 factorial, because of this 5. 12c5 divided by 5 factorial, 12p5, no need to divide by 5 factorial. I hope I have made the point clear. So these shortcuts we will use. So now you can check it out yourself. In the previous slide I have written 10 into 9 into 8 into 7. That is nothing but 10p4. Write it properly. 10p4. 10p4 was the answer. So 10% enter in a bus and 4 seats are vacant. How many ways they can sit? 10p4 ways are there. Okay, yes. And if I want to say in terms of combination, I will say 10c4. Out of 10 persons you will pick 4 person, and then after picking 4 persons you will arrange them. Why you are arranging them? Because you want them to sit on the seats. Okay, so 4 seats are there, 4 persons are there. Let me show you like this. These 4 persons, and there are 4 seats. So how many ways you can arrange? So first person there are 4 choices, second person 3 choices, third person 2 choices, and fourth person only 1 choice. So 4 into 3 into 2 into 1, that is 4 factorial. So that is how I have done it. So 10c4. So from the 10, first of all I will pick the 4 persons. Okay, and then these 4 persons will go and sit on the chairs. So that is 10c4 into 4 factorial. So I hope I have made the point clear to everybody. Okay, so this is the way. So do not say directly 10p4. Say 10c4 into 4 factorial. Why I am saying so? Because you will get more clarity after few slides. We can apply some constraints and all. Okay, so that will create very big problem. So do not try to apply direct formula. That's why I'm not teaching you how to apply the formulas and all. I'm teaching everything with proof, so that you can solve each and every questions very easily. Okay, please take snapshot of this slide also, and take snapshot of this slide also. So try to think everything in terms of combination. You should remember this thing. Okay, so in the next slide I will show you why I am saying these things, why I am saying this. I'm jumping now. See this type of question will come in GATE exam. One person A who is old must get a seat. So I have applied a constraint. So 10 persons enter in a bus, 4 seats are vacant. How many ways they can sit? Such that one person A who is old must get a seat. So directly and directly what you want to say, one person A is already selected. So out of 10, one person is already selected. So now you want to select only 3 persons. From how many persons? Obviously
The voice is not coming, sir.
Yes, I think my internet was gone. So yes, everybody is there. Okay, so let me share this. My screen is visible.
Yes, sir.
Okay. Yes. Yeah. So recording is there. Okay. So till what point everybody have listened? This question I have started. So at start itself, internet was gone, or uh, till what point everybody have listened? Please let me know.
By just started, sir.
Okay, okay. So this thing was clear, na? So so now we want to check that why we are doing everything in terms of combination. Why in terms of combination
Sir,
we are doing?
the screen is not changing, sir. Whatever you're writing is not showing.
Good afternoon, sir. So screen is not shared.
Just a
Yes, sir.
second. Stop sharing is an option. I think I should leave the meeting and I will start it. Okay, or just leave. I am leaving the meeting and I will again join it. Okay, so you please remain here only. I am trying. Yes, my screen is visible now.
Not it, sir.
Okay, now
Yes, sir.
okay. Yes, so let me do it again. So now I think it's visible to everybody, na?
Yes, sir.
Okay. Yes, so now I was just saying that after all, why we are thinking in terms of combination. Okay, so I have told you all these kinds of things. So why these things? So let me show you. Yeah. Yes, any doubt?
No, sir. No, sir.
Okay. Yes. So now the question is, one person A who is old must get a seat. That is a question. Okay. This question is, one person A who is old must get a seat. So I have just continued it. Okay. So 10 persons enter in a bus. 4 seats are vacant. How many ways they can sit? Such that one person A who is old must get a seat. So now how you will solve this kind of question? These type of question come in gate. Okay, because now we have applied some constraints also. So one person A should or must get a seat. That means what? From the 10 person, one person A is already gone. So how many persons are left? 9 persons are left. From these 9 persons, how many persons you will choose? You will choose only 3, because a one person A is already chosen. So you will choose 3. Now after choosing 3 persons and A is also there, so total how many persons you are having? 4 persons you are having. Now you will arrange them on the seats. So how many ways of arranging 4 persons? 4 factorial ways. This is the answer. So now this type of question can never be answered by direct formula 10p4 and kind of thing. So this formula, this type of formula will never give you the answer. So I think you have got it. So what is the step? First step is you pick 3 persons. And after picking 3 persons, since 1 person is already picked, so you have got now 4 persons. Now you will arrange them. So best way is, do not apply formula NPR kind of thing. You first choose them and then you arrange them. Okay. So I have choose 3 persons. Choose 3 persons. After choosing 3 persons, so total 4 persons come. Total 4 persons we got because A is already there. Huh? Total 4 persons we got because A is already chosen. Okay, so now you will arrange them. You will arrange them. So arrange them means 4 factorial ways. Why 4 factorial? It's very simple. 4 you can say 4 chairs are there and 4 persons are there. So how many ways you can sit? So let me write it. P1, P2, P3, P4. P1, P2, P3, P4. 4 persons, 4 chairs. So P1, 4 choices. P3, 3 choices. Then 2 choices. Then 1 choice. So obviously 4 factorial. This is the answer. Okay. Now please take snapshot. I will jump to the next slide. Okay. Next is 2 persons A and B should always get a seat. So now I'm saying 2 persons should get a seat. So from the 10 persons, 2 persons are already gone. So 8 persons are remaining. From these 8, how many you will pick? Only 2 persons you will pick. And how many you will arrange? 4 persons you will arrange. So 8C2 into 4 factorial. Please take snapshot. I will jump to the next slide. I'm jumping now. 4 persons enter in the bus and 10 seats are vacant. How many ways they can sit? So you will say, sir, same question is repeated. No. Now I'm saying 4 persons enter into the bus and I'm saying 10 seats are vacant. So how many ways they can sit? So now again same box method. So now in the in the boxes, what you will fill? Okay. So first of all, tell me how many boxes will be there. Now only 4 boxes. Okay. Less one you will take. So 4 persons and 10 seats. So obviously 4 person cannot sit on the 10 seats. Na? So you have to pick 4 seats. From the 10 seats, you will pick 4 seats, and on these 4 seats, you will arrange the 4 persons. So from the box method, what I will say, so at the first place, say I am having, so first person, I will say first person is having 10 choices. It can sit on any chair. Next, 9, then 8, and then 7. So so 10 into 9 into 8 into 7. So that is nothing but, again, if you try to follow my idea, 10P4 is the answer. Okay. So this is by box method and all. By common sense, what I will say, from the 10 chairs, you will choose 4 chairs and then you will arrange them. Arrange them means you will, you can say persons will come and sit on these chairs. Okay. So now this 10C4 means what? You are choosing chairs now. Pick chair. Pick chair. And then you arrange them. Answer is same. Okay, the only thing is you should remember. Okay, so many times when I used to teach in offline classes, when I just started this subject around way back in 10 years back, then I used to tell the students the first question which I tell, this question. So 10% entering in a bus, 4 seats are vacant and so on. So immediately students try to label them. They will say 10. Okay, 10 is persons. 4. Okay, 4 is the chair. They will label these kind of thing, and I keep on saying them, please do not label these kind of thing. Please do not label. But everybody keep on doing like this. So then I invented a new question, and then I gave this question to them. So those who are by hearting these things, that above we have to write person and below we have to write chair. So they will say like this: above we have to write persons, below you have to write chair. So they will write 4P10. This is clearly meaningless thing. So from the 4 objects we want to pick 10 objects. That is impossible. Okay, that's why please do not by heart any kind of thing. That's why I have made this question. Okay, answer is same, 10p4 only. Previous questions, this question, answer is same. So do not label any kind of thing. What will come above, what will come down. Do not label this kind of thing. So I'm not doing all these kinds of things. So this is my request to everybody. Do not do these things. Okay. Yes. So now what is the basic difference? So now I'm picking the chairs, but in previous scenario I was picking the persons. Okay. So 10c4 into 4 factorial, same answer, but there I was pick persons. Now here I am picking the chairs. That is the basic difference. Okay. Anyhow, for so it's a really beautiful thing. See this I have written here. So what is the beautiful thing? 10 persons on 4 chair or 4 person on 10 chair, both are same according to mathematics. Mathematics is not making any kind of difference between persons and chairs and all. For mathematics everything is same, that is numbers. Okay, mathematics is all about numbers. Okay, yeah, it is not discriminating the things. So for mathematics answer is coming same na. So according to mathematics both are same, like 10 persons and 4 chairs are vacant, or 4 persons and 10 chairs are vacant, and so on. Both scenarios are same according to mathematics. Okay, but actually we know they are not same. Yes, now please take snapshot. I will jump to the next slide. Okay. Next is select 4 toys from 10 toys and give them to 4 children. How many ways? So what I want to say, we want to select 4 toys from the 10 toys. Okay, and we want to give them to 4 children. So how many ways will be there? So since I have used the word select, so you will say okay, 4 from the 10 na? So select 10 from 4. Sorry, select 4 from 10. Yeah, from the 10 toys you will select 4 toys, and now what I have said, you give them to 4 children. So clearly what I want to say, 4 toys are there, so first toy 4 choices and so on. So obviously why I want to arrange them directly I want to arrange them, so I will multiply it by 4 factorial. So answer is coming to be 10p4. So now see this is a really exceptional question. So you will see the word select. If you by heart the things, that will create very big problem. That's why many students feel permutation combination is difficult and all, because they try to by heart some things. If even you by heart one simple concept, you will face really very difficulty in this topic. So do not by heart anything. Okay. Yes. So since the word is select here, now in your back of the mind you will keep on thinking, okay, combination, but option is this. So you will get confused how permutation is coming. Select word was there. Okay, so option will be in GATE exam you will find the option 10p4, 10c4, and most of the student will pick 10c4 because of the word select. But no, it is not the case here. Okay, select is there, but still 10p4 is the answer. Why 10p4 is the answer? I am not by hearting anything. I am simply doing what what the question is saying. I am just breaking the question and step by step I am solving. First is select 4 toys from 10 toys. Okay, I am done. I have done it. 10c4. So I have selected 4 toys from 10 toys. Select 4 from 10 and give them to children. And means what? Your work is not yet over, so you have to give them to children also. Work is not yet over, so multiplication will come into the picture. And then give them to 4 children. So obviously 4 toys, 4 children, you want to arrange them. So 4 factorial is. So finally mathematically I have shown you 10c4 into 4 factorial is nothing but 10p4. We already know all these things. Okay, if you still have doubt I can solve it. 10c4 means what? I have told you the shortcut, 10 into 9 into 8 into 7 divided by 4 factorial and multiplied by 4 factorial. So this and this got cancelled. So this is nothing but, I have told you many times, 10p4. Please take snapshot. I will jump to the next slide. Okay, I'm jumping now. Next is select 3 persons from 10 person for the post of president, vice president, and manager. How many ways? Again, same thing. So from the 10, you will pick the 3 and then you will arrange them. Why? Because one of them will be president, one of them will be vice president, one of them will be manager. I think you have got it now. So you just consider them as chair. For mathematics, everything is same. You consider them as chair: president chair, vice president chair, and manager chair. And 3 persons are there. So what are the ways they can sit on them? So 3 factorial ways. So 10c3 into 3 factorial. Again 10p3 is the answer, and in spite we have a word select in it. Again we are getting 10p3 as the answer. Okay, so it's wordings are different. The previous question and this question are almost similar. Okay, please take snapshot. I will jump to the next slide. Yes, I'm jumping now. So there are 5 letters A, B, C, D, E. How many 26 letter passwords are possible? How many 26 letter passwords are possible? So what I will say, by common sense, I think you have got it now. So 26 letters, so you will make 26 boxes. So at the first place, since password, that means what? Unlimited repetition. Unlimited repetition means first place 5 choice, second place 5 choice, third place 5 choice, and so on. Okay, so what will be our answer? 5 into 5 into 5, 26 times. So 5 power 26 is the answer. Okay, so that's why see this, since unlimited repetition, formula was n power r. What is n, what is r, I have not told you, because no need to tell you all these things. Best way is make the box method and get the answer. Okay, so see this now, permutation. This is the question of permutation with unlimited repetition now. Okay, see this if you have doubt. Where are the categories? Yeah, these are the categories. So permutation with unlimited repetition, n power r was the formula. What is n, what is r? It hardly matters to me. I'm not telling you all these things because fundamentally you will get confused. Okay, so simply apply the box method and get the answer. Many of you, if you do not know this box method, many of you will get confused. What will be the answer? 26 power 5 or 5 power 26? Okay, and both options obviously will come in GATE exam. Okay, so answer is 5 power 26, 26 power 5 is wrong. Why it is wrong? Because 26 letter password. Na? So 26 boxes and each place 5 choices. So 5 into 5 into 5, 26 times, it is 5 power 26. Okay. Now if I tell you what is n, what is r and so on, you will definitely get confused. What is, so you will get confused. Answer is 26 power 5 or 5 power 26. You will definitely get confused. That's why I'm not going into detail of all these formulas and all. Just leave them, simply leave them, concentrate on the box method. This is the best way because it can handle constraints also. So by applying formula you cannot handle constraints. Okay, that is the problem. Yes, please take snapshot. I will jump to the next slide. Okay, I'm jumping now. So see, sometimes they can ask this question in NPR. N should be greater than equal to R. This is the restriction. Like for example, I can say 5p5. This is okay. If I say 5p4, this is okay. 5p2, this is okay. But if I say 5p6, this is not okay. This is 0. This is impossible. Why this is impossible? Because from the 5 objects, I want to arrange 6 objects. That is meaningless thing. How you can arrange from 5 objects, you can arrange 6 objects? That is not possible. So whenever you find the thing not possible, so you will not give answer as not possible because it is a counting problem. Permutation combination is used for counting the things. So obviously you will give the answer as 0. Are you getting it? So immediately whenever you feel that something is impossible, you will give the answer 0 because they are counting problems. We are counting something. That's why. Okay, and n power r is there is no restriction, like n can be greater than r, n can be less than r, and so on. Okay, so proof of this is here. So see this answer was 5 power 26 na. So 5 is n, r is 26. So r can be greater than n also. So here r can be greater than n also in n power r, but in NPR r can never be greater than n. R greater than n not possible, but here it is possible. So there is no restriction at all. N can be greater than, n can be less than, n can be equal. Anything can be done here. Okay. Yes. Please take snapshot. I will jump to the next slide. So next, another kind of questions are coming. So game questions I am concentrating now. Okay, category by category we will keep on doing. So games kind of thing I will do. So 10 games are played between two teams A and B. Outcome is either A win, B win or tie. How many outcomes are possible? This is very simple. 10 games are played na, between two teams A and B. So first game, tell me about first game. What is the possibility of the outcome of the first game? Either A win, B win or tie. So 3 possibility. Second game, again 3 possibility. Third game, again 3 possibility. So I think you have got it. 10 games. So 10 boxes you will make. Everywhere 3 possibility. Everywhere 3 possibility. So 3 power 10 is the answer. Okay, please take snapshot. Okay, I'm jumping now. If there is no tie, so tie is not the option. So how many ways? Obviously 10 games. So either A win or B win. So everywhere 2 possibility. Okay, so 2 power 10 is the answer. So simple. Okay. Yes, I'm jumping next slide. Next is no tie in first and the last game. This is the beautiful type of questions. Nah? That's why I'm again and again showing you box method only. Without box method, you cannot solve these kind of questions. No tie in first and the last game. So what do you mean by this? This is the first and this is the last game. So in the first game, no tie. So what do you mean by this? So only either A wins or B wins. So 2 possibility here. In the last game again 2 possibility. But rest everywhere 3 possibility. So how many times 3 will come? 8 times. Okay. So 2 power 2 into 3 power 8. This is my answer. If anybody is feeling any difficulty, please let me know. Otherwise, I will jump to the next slide.
Clear, sir.
Okay, so I'm jumping now. Next is A won in first and second game. If the condition is A wins the game, A win the first and second game. So in the first box, only one possibility, that is A win the game. Second box, only one possibility, that is A win the game. And for rest of the boxes, 3 possibility everywhere. Okay. So 3 power 8 is the answer. So let me write it properly. 1 power 2 into 3 power 8. So it comes out to be 3 power 8 only. Okay. Yes. Next is dice problem. 10 dice are thrown. How many outcomes? Again, very simple. So first dice 6 possibilities. Second dice 6 possibility, and so on. So 10 times 6 power 10. Very simple. I think I should not waste time here. These are very simple things. Please take snapshot. Okay. Next is first and last dice 6 is the outcome. So this is important, and this question come in gate. So while making box, you will do silly mistakes. So first and last 6 is the outcome, and rest everywhere 6. So you will get confused. Okay, many of you you will answer 6 power 10, and option was 6 power 10 also. Okay. So in hurry you will do this kind of mistake na. So here 6 is the outcome, here also 6 is the outcome, but here these are the choices. So you will say there is only one choice here, there is only one choice here, and for everywhere there is only there are 6 choices everywhere. Okay. So see this, they have picked the number very wisely. So that's why I keep on saying that IIT's professor have lots and lots of experience. They are teaching from the past 20-25 years. So they will make a question in such a good manner that most of the students will get confused in GATE exam. Okay, in hurry you will do this kind of thing, na? So 6 here, 6 is the 6 is the only outcome, and here these 6 are the choices. So many of you will say, okay, 6 into 6, 6 power 10 is the answer. In hurry you will do it, but actually this 6 is the outcomes, only one choice is there. This 6 is the outcomes, only one choice is there, and rest everywhere 6 choices. So how many choices? 6 power 8 is the answer. Okay, so 6 power 8 is the answer. So how 6 power 8? 1 power 2 into 6 power 8. This is the answer. And this is a gate question. Please take snapshot. I will jump to the next slide. Okay. Next is first two dice shows odd number. Okay. So total 10 dice we have thrown. First two dice shows the odd number. First dice is showing odd number. Okay. First, just a second. Just a second. Yes. Yes, so first two dice shows the odd number. So how we will do? So first dice odd number, so 3 possibility. Second dice odd number, 3 possibility. So 1, 3 and 5. Okay, 3 odd numbers now. For rest everywhere, 6 possibilities. So 3 power 2 into 6 power 8 is the answer. Please take snapshot. I will jump to the next slide. Okay, I am jumping now. Coins. So now we will see some coin problem. 10 coins are thrown. How many outcomes? Very simple. 10 coins have been thrown. So what are the outcomes? So first two outcomes, head or tail, next head or tail, head or tail, head or tail, and so on. So 2 power 10 is the answer. Please take snapshot. I will jump to the next slide. Okay. So first two coins shows the head. So 10, first two coins have shown the head. So here only one possibility, here also only one possibility, rest everywhere two possibilities. So 1 power 2 into 2 power 8, that is nothing but 2 power 8. This is the answer. Please take snapshot. I will jump to the next slide. Next is first two coins, same outcome. This is important. This is important. What I'm saying is first two coins shows same outcome. So what do you mean by same outcome? First two coins, either first two are saying head, okay, or I can say first two are saying tail, okay, and rest everywhere two possibilities. So there is only one possibility here, that is head. There is only one possibility, that is there is head. Rest everywhere two possibilities, so 2 power 8. So here only one possibility tail, only one possibility tail. Rest everywhere two possibility, so 2 power 8. So 2 power 8 plus 2 power 8, that is 2 power 9 is the answer. If you have any doubt why it is coming, so you can think like this. So answer will be 2 power 8 plus 2 power 8. Consider it as x. So x plus x is nothing but 2x. 2x means what? 2 multiplied by 2 power 8. So 2 power 1 into 2 power 8, that is nothing but 2 power 9. This is the answer. Please take snapshot. I will jump to the next slide. Yes. Any doubt here?
So,
Yeah.
um, just because like head and tail we have got a
Mm-hmm.
choice here. We have
Mm-hmm.
first way and second. That's why we have to add them.
Mm-hmm. So no, no see, after, see, if we have head and here we have two choices, so our
Yes,
work is over now, and
but
here
we
also
have
our
to.
work is over.
Hmm.
So that's why we will do or this or sense is coming now. So I will apply plus.
Okay, sir.
If and sense is coming, then I will apply multiplication.
All right, sir.
Because and means work is not yet over. Shirt and pant I have to wear. Then I am dress up. Okay. Yes. So, okay. Please take snapshot. I will jump to the next slide.
All right, sir.
Next is answer sheet kind of question. So 60 questions are there and each question is MCQ. MCQ means we have 4 choices. That is, one is correct. Okay. So how many distinct answer sheets are possible if student is not allowed to skip any answer? Okay. So 60 questions are there. Each question is MCQ having 4 choices. So only one is correct. MCQ means only one is correct. So how many distinct answer sheets are possible? A student is not allowed to skip any answer. So every student has to give every answer. So how many answer sheets are possible? Distinct answer sheets are possible. So simple question, 60. Everywhere, 4 possibility. Okay. So you have to take either A, B, C, or D. Here also A, B, C, or D, and so on. So 4 choices, na? So 4 choices. So total 60 questions are there. So 4 power 60 is the answer. Okay, so just to confuse you, they can give answer like this also. 4 is nothing but 2 power 2. So 2 power 2 power 60. It comes out to be, I think you have got it, 2 power 120. So they can give answer like this also, just to confuse you. Okay. Please take snapshot. I will jump to the next slide.
Done, sir.
Okay. So if student is allowed to skip any answer, what will be the our outcome? If student is allowed to skip the answer. So everywhere, see, everywhere we will be having 4 choices over there. One more choice will come, that is you can skip it. So 5 choices everywhere. So 5 power 60 is the answer. Okay, I am jumping to the next slide now. So 60 questions, 10 MSQ and 50 MCQ. How many answer sheets are possible if candidate is allowed to skip the question also? So this is important. There are 10 MSQ also. So what do you mean by MSQ? So 4 choices are there. You can say either one of the choice is true. So if one of the choice is true, then how many possibility? 4 possibilities are there. Now I can say 2 choices can be correct also. So 2 choices correct means what? From 4 you want to pick 2. Okay. So A, B, A, C, A, D, and so on. How many will be there? 4 C2, that means 6. Are you getting it? 4 C2. 4 into 3 divided by 2. So it will be 6 choices. Then from you can say 3 can also be correct, like A, B, C, A, C, D, and so on. So how many ways will be there? 4C3 ways will be there. So what is 4C3? 4 into, okay, let me tell you one more thing. 4C3 will be same as 4C1. Okay, so you should remember this thing. NCR, that is same as NCN minus R. Like 10C8. 10C8 is really very difficult to solve. Na? 10 into 9 into 8 into 7 and so on divided by 8 factorial. That will create a lot of problem for us. So I will change it into 10C. 10 minus 8 is 2. So I will write it 10C2. So 10C8 is same as 10C2. So because NCR is same as NCN minus R. You can check it out. Algebraically they are same. You can check it out. Okay. And if you want me to say intuitive proof, I will say like this. From 10 objects, you are picking 8 objects. And what so indirectly you are leaving 2 also, na? From 10 objects you are picking 8 objects, so indirectly you are leaving 2 also. And same scenario I can say like this, from 10 objects you are picking 2 objects. Okay, so indirectly same thing, na? From 10 objects you are picking 8 objects, or you can say From 10 objects, I am leaving 2 objects. So obviously both will be same. So 10C8 and 10C2 both are same. I think you have got it. So same thing. So 4C3, I will say 4C1. So 4C1 is nothing but 4 only. Why? Because 4 divided by 1. I think you have got it. 4C1 is 4 only. Yes, so 4 choices will be there. Okay, and then all can be correct, A, B, C, D. So only one choice will be there. All are correct. And if you want to skip it, there is one choice. One choice for the skip. So how many ways are there? 1 plus 1 plus 4 plus 6 plus 4. So 6 plus 4, 10. 10 plus 4, 14, 15 and 1, 16. So 16 choices are there. And let me tell you one more way of doing it. So what is the one more way? So I will say like this. So from the there are 4 options now. From 4 options you are picking none. That means you are skipping it. Or from the 4 you are picking 1. Or from the 4 you are picking 2. Or from the 4 you are picking 3. Or from the 4 you are picking 4. So what is this? This is nothing but 2 power 4, that is 16. So this is again a very beautiful identity. Let me tell you. Identity is NC0 plus में NC1 plus में NC2 dot 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 NCN. It is nothing but 2 power n. So 4C0 plus 4C1, 4C2, 4C3, 4C4. What it will be? 4 is up na. See this. So 2 power 4 is the answer. NC0, NC1, NC2, NC3, NCN. So n is up na. So 2 power n was the answer. So same scenario you will say 16. So just for the sake of proof, I have given you all these things. Okay. Otherwise, I can say directly. So from now onwards, you will say directly 4C0, 4C1, 4C2, 4C3, 4C4, 2 power 4 is the answer. So from the 4, I can pick any numbers. Na? So it will be 2 power 4, that is 16. I think you have got it. So for MSQ, 16 choices. So 10 MSQs are there. 10 MSQs are there. Each and everywhere 16 choices. So 16 power 10 will come from here. Now 50 MCQs are there, and everywhere 5 choices will be there because we can skip also. So 5 power 50 will be there. So 5 power 50 for MCQ, 16 power 10 for MSQ. So answer sheet, see, you have just attempted all MCQ. Work is over? No. You have to attempt MSQ also. So I will do multiplication. So final answer will be 5 power 50 into 16 power 10. Okay, yes, you can take snapshot. I will jump to the next slide. Okay. Yes, I'm jumping now. So if no skipping is there, then very simple. So just subtract 1, 1. So 5 minus 1 will be 4. So 4 power 50. And here 16 choices were there, na? 16. So I will skip 1 because 4C0 is 1 only. So I will skip 1. That is 15 power 10. This is my answer. By the way, you should know 4C0 means what? From 4 objects, you are picking 0 objects. How many ways? Obviously 1 way. You are picking nothing. So 4C0 is 1. You have to remember this thing. Okay. Similarly, NC0, that is 1 only. And algebraically also you can check it out. So n factorial divided by C. What is NCR? N factorial divided by R factorial n minus R factorial. So n factorial, R factorial, what? 0 factorial multiplied by n factorial. 0 factorial is 1. N factorial cancelled. So answer is 1. So NC0 is 1. Okay. You have to remember this thing. Yes. So no skipping. This is the answer. 4 power 50 into 15 power 10. Please take snapshot. I will jump to the next slide. I'm jumping now. Yeah. Yes. Okay. Okay. Next is gate question is coming. So 10 couples were invited to party. Condition is given as wife must come with husband, but husband can come alone. How many types of gathering is possible? 10 couples are invited in a party. What is the condition? Wife must come with husband, but husband can come alone. So there is a very small twist in the question. So since it is a gate questions are not difficult. There is a very small twist in it. If you are able to guess it, you will get the answer. So you will make a box, 10 couples. So how many choices for the first couple? What they are saying, wife must come with husband. Okay, wife must come with husband. Husband can come alone. Okay, husband can come alone. Any other way? Let me give you an example. If I invite you for a party, then is it compulsory that you will come to the party? No. You can skip that also. If somebody invites you, it's your choice. Na? You go or you do not go. So another possibility is nobody goes. No one goes. Neither husband nor wife. Nobody goes. Okay. So another possibility was wife alone. But wife alone is not allowed. I have told you. Wife must come with husband. Okay. Wife cannot come alone. So wife and husband, husband and nobody came. So 3 possibility. So for every couple we have 3 possibility. So answer will be 3 power 10. Many of students take 2 power 10 as the answer, but 2 power 10 is not the answer. Why? Because it's obvious when somebody invites you to the party, it's your choice. You go or you do not go. So this was the only small twist. So it's allowed that you do not go. Okay. So 3 possibility every place. Every couple has 3 possibility. So 3 into 3 into 3, that is 3 power 10 is the answer. Please take snapshot. I will jump to the next slide now. Okay, I'm jumping now. Okay, so final summary is permutation with no repetition. Formula is NPR, or you can think in terms of combination NCR into R factorial, or you can apply box method. So which is the best method? Box method is the best because we can apply constraints and all. Permutation with unlimited repetition, formula is N power R, but we will not apply it because best is the box method, because with box method we can apply constraints also. So for both the scenarios, permutation with no repetition, permutation with unlimited repetition, box method is the best. Please take snapshot. I will jump to the next slide. Okay. Next is permutation with limited repetition. So now we are going to start the next category, that is permutation with limited repetition. Formula for permutation with limited repetition is this: n factorial divided by n1 factorial, n2 factorial, n3 factorial, and so on. Let me explain it how we are doing it. So how many 3-letter words are possible from ABA? So this is a word ABA. So 3-letter means obviously we'll consider all the 3. So directly and indirectly the question is jumbled words from this word ABA. So now the problem is these are the A and A are same. Now if I say A, B and C, how many jumbled words are possible from this word? Okay, so obviously 3-letter words we will take because we will do jumbling. So how many possibilities? So I will make a box. At first place three choices, second place 2 choices, third place 1 choice. So 3 into 2 into 1, 6. 6 is nothing but 3 factorial. No? 3 into 2 into 1, that is nothing but 3 factorial only. So 3 factorial, you can say jumbled words from this ABC. Okay, and how we have done it, I think you have got it. So ABC, first I will consider it here, ABC, then BAC, okay, and then I can say C. First I have taken C at the end. So ABC, BAC. Now I will take C in the middle. So now here AB and then BA. Here we will speak the C. And the last scenario will be I will put C at the start. Now I will say AB and then I will say BA. So these are the total 6 jumble words from ABC. I think you have got it, how I have done it. Okay, now what is the scenario for ABA? Now try to concentrate. For ABA, what I will do, so try to think it as A1. Now if you consider them as different, you will think like this only. Okay, or consider this A as C. You will consider this like this. Okay, but if C is replaced by A, then what we will get? C. I will say like this. If C is replaced by A, then this will become ABA. So now this will become like this. This will become like this. This will become like this. This will be like this, and this will be like this. Okay. So now clearly see this A, B, and ABA, and this is also ABA. So these are one only. So why you will consider them as two? You will consider them as one. Next is B double A. This is B double A, no? And here also we are getting B double A. Let me use another color. This red mark. Okay. And then we will say black mark. AAB, and here also AAB. Are you getting it? So when A and C are same, that means we have a repetition kind of thing. Then these two are merged to one. These two are merged to one. These two are merged to one. So directly and indirectly, I have made group of two, and I am considering them as one. So I have divided by a 2. So similarly, I will say ABA. There are 3 letters. So I will simply say 3 factorial ways to arrange them. But in these 3 factorial ways, A and A are same, na? So I will divide it by 2. Why I am dividing by 2? Because obviously they are coming same, na? That's why. More precisely, I should say I am dividing by 2 factorial. Okay. So if you want to say, if I say like this, if I am having A, all the 3 are same. So how many ways of arranging them? Only one. Now if you consider them as different, A1, A2, A3 or A, B, C, then 6 ways will be there. Now all these 6 ways will be merged to one way, na? Because now A, B, C all will be same. So all will be merged to one. So directly and directly what I want to say, 3 factorial ways to arrange them, considering them they are different, and then I am dividing by what? 3 factorial only. Why? Because I will arrange them, but their arrangement will not produce any other extra result. Okay, so that's why I'm dividing. So now I can generalize it. Okay, for example, if I am saying A, B, B, C, C, how many ways to arrange them? Okay, so let me take it another way. Yeah, so double A and 3B, how many ways to arrange? So I will consider them, these all are different. So I will say 5 factorial. But since 2 A's are repeated, so I will divide it by 2 factorial. Now since these 3 are repeated, so I will divide it by 3 factorial. So this is my final answer. Same is the case. N factorial divided by N1 factorial, N2 factorial, N3 factorial, and so on. So N is what? Total number of words. N1 is first repetition, N2 is second repetition, N3 is third repetition, and so on. And I think you have got it. Okay, please take snapshot. I will jump to the next slide. Okay, I'm jumping now. Next is Mississippi. Mississippi. How many jumble words are possible from this word? Okay, so whenever I will use permutation with limited repetition, I will refer to this problem. I will say Mississippi problem. Okay, Mississippi problem means permutation with limited repetition. Like this, I will say everywhere. So now I will not say this permutation with limited repetition and all. I will simply say it is Mississippi problem. Okay, so how many jumble words? So how many jumble words? So how many times? Say letters. See this. M is repeated 1 times. Only 1 time M is having. I is repeated 4 times. S is repeated 4 times. P is repeated 2 times. So how many words? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yes. So see this. 4, 4, 8, 10, 11. Yes. First class. We have done it correctly. Okay. So now how many jumble words? I have told you 11 factorial. Total are 11. Assume all are different. 11 factorial divided by their repetitions. 4 factorial. So let me write it properly. 1 factorial, 4 factorial, 4 factorial, 2 factorial. So final answer will be 11 factorial divided by 4 factorial, 4 factorial, 2 factorial. This is my answer. So please take snapshot. I will jump to the next slide now. Okay, I'm jumping now. Yes, so Mississippi problem, I have told you, permutation with limited repetition. As soon as I will say permutation limited repetition, I will say, okay, it is Mississippi problem. So the way we have solved Mississippi problem, you will solve all this kind of problem. So how many jumbled words from Mississippi? I have told you 11 factorial, just a repetition, 4 factorial, 4 factorial, 2 factorial. This is the answer. Okay, let me jump to the next slide now. I'm jumping now. So how many jumbled words from this word equation? So how many words are there? Letters. 1, 2, 3, 4, 5, 6, 7, 8. 8 letters are there. 8 factorial divided by anything is repeated? No. Answer is this only. 8 factorial. Jumbled words from this. 1, 2, 3, 4, 5, 6. So 6 factorial. How repetition? Only A's are repeated 2 times. This is my answer. So these are very simple things. Okay, very simple things. So what is the category of the problem? Permutation with limited repetition. Why I'm saying limited repetition? Because A can be repeated only 2 times. I cannot repeat A multiple times. That is the basic meaning of limited repetition. Okay, please take snapshot. I will jump to the next slide. Next is I will apply some constraints on this Mississippi problem. Start with P. What if we say start with P? So simply we will make box like this. So start with P. So for rest, how many are remaining? 10. Okay, because we have taken 1 P. So obviously total were 11. So 1 P we have taken. So how many places are left? 10 places, or 10 letters are left. So obviously 10 factorial ways to arrange them. So now 1 P is already taken now. So only 1 P is left. So now you will not consider that P is repeated at all. Only 1 P is left, so no problem. So S is repeated 4 times, I is repeated 4 times. P was repeated 2 times, but I will not consider this as a repetition because 1 P is taken. You just separate it out. So now I will say 10 letters are remaining. So now you just arrange them. So 10 factorial divided by 4 factorial, 4 factorial. This is the answer. So I hope I have made the point clear. If anybody is having any kind of difficulty, please let me know. Okay, I'm jumping to the next slide now. So does not start with P. This is important. What do you mean by does not start with P? So it is complementary problem. Does not means complementary problem. So what do you think? You will be thinking, okay, it is not starting with P, so it can start with M, then start with I, start with S. No, this is very long method. No doubt you can do it, but it is a very long method. Why you want to do this? When I'm saying does not start with P, I have got it. Starting with P is what? 10 factorial divided by 4 factorial, 4 factorial. Starting with P is ready with us. Now how many total are possible? Total were 11 factorial divided by 4 factorial, 4 factorial, 2 factorial. I think you know na Mississippi. I have told you 11, 4, 4, 2. Yes, so total were this minus this. You will get the answer. So simple. Why you want to do this long method? This is my final answer. Okay. So complementary problem always solve like this. So all possible from all you subtract the desired. Okay. So you will get this thing. Okay. Please take snapshot. I will jump to the next slide. So sometimes probability kind of questions have been asked. Probability of E, I think you already know. Number of ways to get the E and divided by sample space. So simply you should say like this. Okay. So favorable divided by total. That's it. Roughly I will write favorable ways divided by total ways. So they can ask question like this. Probability, we pick a word randomly from all jumbled words of Mississippi and it start with P. So favorable start with P is 10 factorial, 4 factorial, 4 factorial divided by total. Total what we were having? 11 factorial divided by 4 factorial, 4 factorial, 2 factorial. So just solve it and get the answer. Okay. So I think we can easily solve it here itself, no problem. 4 factorial, 4 factorial, this is gone. Okay, and then 10 factorial multiplied by 2 factorial divided by 11 factorial. Now, so 11 factorial nothing but 11 into 10 factorial. This and this are gone. So finally 2 by 11 is the answer. It's very simple calculation. So I have done it. 2 divided by 11 is the answer. Yes. So if they say it does not start with P, does not start with B, so I think you already know na, probability of not happening is 1 minus this. Probability is 1 na, so 1 minus 2 by 11, it comes out to be 9 by 11. Okay, I think you have got it. If anybody is facing any difficulty, please let me know, I will explain it. Okay then, so we will keep till here itself. Time is up. So in the next class we will resume from here itself. Okay then.
Thank you, sir.
Yeah, thank you. I'm winding up the class. Okay, thank you so much. Bye bye.